Got it. So, hello everyone. This is the Degree to Career Fall 2020 Lunar Council Conference, and it's hosted by Lunar Council, and we're the Aerospace and Computational Engineering Council for undergraduates. So for our table of contents, we're going to start off with a Lunar Council introduction, and then the panelist introduction, prepared questions, and then the audience Q&A. So for our Lunar Council introduction, we are the undergraduate student body council. Like I've said, LUNAR stands for Leadership, Undergraduate Networking, and Recruitment. And we provide continuous feedback to and from the ASE and COE department. And Lunar Council is comprised of the student leaders for the aerospace and computational engineering organizations, as well as class presidents and class representatives. Okay. Oh, thank you. Okay, let me present. I'm not in present mode. I've been notified. Okay, great. So, okay, some of our ongoing project examples have been the curriculum review and preparation for future catalog changes. And we have collaboration with alumni, such as members from the EAC, like a lot of you today. Thank you so much for coming. And we have student body representation through town hall meetings and socials and feedback from students. Okay, and now we have our panelist introduction. And with this, I'm just going to ask the panelists to have a self-introduction and briefly describe their personal career path, as well as a description of your industry and its various jobs that it has. So if there is anyone who would like to go first, that'd be great.
I can go first. Yep, we spoke over each other. Go ahead.
No, I was going to ask how much time do we have to introduce ourselves?
You have a pretty good amount of time.
Okay. All right. Well, I'll start then. So yeah, my name is Laurent White. So I work at ExxonMobil in the research organization, the Corporate Strategic Research Organization at Exxon. So I've been, I'm going to, I guess, operate in reverse here. So I've been at Exxon for almost 11 years, working in research. Before that, I was a postdoc at Princeton University in ocean modeling. And before that, I did my PhD in applied math, but more specifically actually on numerical ocean modeling as well. And I have a background in applied mathematics. So that's my high-level career path in reverse. So, ExxonMobil, like a lot of oil and gas companies, are especially the vertically integrated oil and gas companies, are pretty particular because there is a wide array of different jobs, especially in research. This is before. But this is foremost a technology company, right? We're driven by the price of oil and gas, and so the only way you can be competitive in an environment like ours is to be better in technology, right? And so research is really key in oil and gas, and it's across all sectors. And so if you look at so I'm assuming that, not a lot of you are familiar with the oil and gas industry, but there's just three key sectors in oil and gas. And there's the upstream, where you do exploration and development of hydrocarbons, and then the downstream, where you have to transport and supply hydrocarbons to refineries and then refine hydrocarbons into gasoline, for example, and then the chemicals sector, where you create chemical products. And so in each one of these sectors, technology is key, and engineering jobs are very important to drive value into the business. And so, I have a background in computational mathematics. And so I've been working mostly in the upstream sector, so, very large scale computational problems. And so if you're looking at the two areas in the aerospace and computational engineering department, that would be more the computational engineering part, where you look at physical problems. It would be like wave propagation or flow in the subsurface, and you have to develop new ways to solve these very large scale problems to predict what happens in the subsurface, for example, and then to make very important business decisions. And so these algorithms are complex. They require the use of very large scale computational infrastructures. And it's really fascinating. And that's the way you can be competitive, by being better or developing new technology, compared to your peers. So that's me, and I'm currently a section head within the corporate strategic research organization, section head for computational physics, and so I'm leading a team of about 10 researchers, developing these new ways of solving very complex problems. So I'll pass the baton to someone else.
I'll go ahead and go if that's okay. My name is, can you guys hear me okay? Okay.
Yep, all good.
All right, good. My name is Dan Deans, and I am the Chief Operating Officer for Millennium Engineering and Integration Company. We're about 1,000 employees. We do spacecraft and ballistic systems development, mainly for the U.S. government, in a lot of high-end engineering and classified type roles. And we have folks all over the U.S. I graduated from University of Texas in 1990 with an aerospace engineering degree, and I'm very proud of that. And have spent most of my career working in aerospace, although I've spent time also working in the semiconductor equipment industry as well as in the chemical industry. So I have done a little bit of on the production side, which I guess what might be considered downstream. I serve on the external advisory committee here for the Aerospace Engineering Department, and am a proud member of the Distinguished Alumni Group for Aerospace Engineering. So very, very glad to be here and excited to talk to you guys today.
All right, well, I'm Chad. I guess I'll step up and go next. So Chad McFarland, I work at the Boeing company. I'm in the research and technology group. That's my current job. Graduated from the University of Texas in the aerospace department, specializing in orbital mechanics at the time. So I guess a little bit of career path. I had an opportunity there was several German researchers and students that had come back and forth between the University of Texas graduate program and Germany. DLR is sort of their equivalent of NASA. And so I got to go do a project there. And I remember wanting to do orbits and these deep space missions. And I think after a summer of doing it, we were doing solar electric and solar sail technology to the main belt asteroids and calculating lots of orbits. And somewhere along the way, I thought to myself, boy, it's going to be about 20 years before this becomes a real satellite, right? And at that point, I made up my mind that I wanted to go work for a satellite manufacturer because I wanted to have that gratification of actually going and building satellites and seeing the product. So basically then I applied for lots of jobs at satellite companies and ended up going and working for the Hughes Space and Communications Company in Southern California, to the shock of my parents who were on the East Coast. But I really wanted to build satellites. And that's what I did. And I kind of did a career or a tour through the satellite industry in reverse order, which I think was hugely valuable. Started out working on flight software sort of for the spacecraft that I was working on, got involved in doing all that development testing. Once that was ready, I started helping out with some of the ground procedures and how to do station keeping and such. A little bit later, after launching some of these and working in the Mission Control Center, I ended up going and volunteering to train our new customers in their brand new satellites. So think about like DirecTV and these distribution communication type satellites is what I was working on at the time. At some point of traveling around the world for about a year and a half, not knowing anybody because I would only be someplace for like 3 months, I decided to go back and take a job back home. And then I basically moved upstream into the factory where we would win the contracts, produce the satellites, test them out, integrate them together, and then do sort of all of the work to take them to the launch vehicle and that type of thing. From there, I moved one step forward and I took a job in our design center, technically helping with the attitude control and some of the aspects there, planning, working on the proposals. At some point, I said, why can't we design our satellites better? And so then I got I guess I worked my way into a job where we got to redesign how we did our design center. We teamed with a professor at Caltech and with some experience at JPL Team X and redid our satellite design center too, and it was a great success. I guess in doing that, then I got interested in more of the software and the tools and the stuff that you need to do to make the satellites. So then I took some jobs to work in more of the defense side of our business, and we did basically systems and prototypes and pathfinders for space superiority type missions for the Air Force, and that was interesting. At some point, I had kids, and LA is pretty expensive, so we decided to move to Seattle, which was more affordable at the time. Now I don't think so much. And I got to work in more of the research and development side of the house, and we was working on what we called at the time these planning and decision aids. Turns out that a lot of the techniques there were more in the areas of machine learning, statistics. So I ended up working there for a number of years, and then there was an opportunity to start up a new research and development group in artificial intelligence in Huntsville, Alabama. And so I took that opportunity, and I've been doing that for about the last 6 years. So I'd like to say, and along the way, Boeing purchased Hughes Spacecraft Company. And so it's been sort of a journey of different assignments and opportunities within our own company at different sites. And I tell my wife I've basically drug her around the world or around the U.S. on a tour of Boeing sites. Right? It's basically our joke. As far as our industry and our job, I think you probably know a lot of what we do as a OEM, original equipment manufacturer. Sometimes people think about the products we do, basically things that fly, but also we work a lot in the support and services of these. And I think with the computational engineering, there's a good tie there on digital twins and physics-based simulations that we do. So I think lots of opportunities there. So thank you. It's been an exciting career so far. Happy to talk to you today.
Great. Thanks so much, Chad. Do we have any other panelists who would like to go next?
I can go if you want, Courtney.
Yeah, that'd be great. Okay.
My name's Scott Erwin. I work at the Air Force Research Laboratory. I'm in the Space Vehicles Directorate, which is in Albuquerque, New Mexico, Kirtland Air Force Base. I was born in Brooklyn, raised in upstate New York in the Finger Lakes. Not a U Texas alum. I did my undergrad at RPI in upstate New York, and then I did my master's and PhD at the University of Michigan in Ann Arbor. All of that was in aerospace. And I'm kind of an anomaly. I started at the Air Force Research Laboratory in 1997, and it's been my only job since then. I started out working in large precision space structures and vibration isolation and control. guidance, navigation, and control for spacecraft. I've moved from there into spacecraft communications, and now I'm heading up a lot of our spacecraft autonomy work at AFRL. I've been the PI on about 6 on-orbit experiments at this point. Some just experiments on a satellite, other ones whole satellites. The latest is our Eagle Mycroft mission, which we just ended the science program of recently. So that's me. A little bit about AFRL. AFRL is a government laboratory. We're not a contractor or anything like that. We're staffed by military officers and federal civil servants like myself. We support the Air Force and now the newly formed Space Force, which is my primary customer, doing everything from basic research, kind of pencil and paper theoretical work, all the way through prototyping and even life cycle support, like post deployment or work like maintenance and improvements to those kinds of things. AFRL is headquartered in Dayton, Ohio. If you don't know anything about it, it is run by a 2-star general, and there's I think 8 or 9 directorates. We keep changing them. Sensors, directed energy, materials, information directorate, munitions directorate, aerospace systems, space vehicles where I am, human effectiveness, and then also the Air Force Office of Scientific Research, which funds a lot of academic research. And really what AFRL's function is we are supposed to be taking in as much of the good research that's done out in the world, really. We work both nationally and internationally, and try to figure out which of it might apply to some of the problems the Air Force and the Space Force has, and then put it through the D and the R&D, the development process, to mature it and work out all the issues with it that are going to be necessary to make it robust and reliable enough to put into an operational military system where, in general, in some form or another, lives are eventually at stake. So that's kind of our function, is to retire risk on new technologies so that they can be incorporated in a cost-effective and kind of reliable way. And AFRL, as I mentioned, we work across the entire what we call, specifically Space Vehicles Directorate works across the what we call National Space Security Community. That's NRO, NASA, Missile Defense Agency, DARPA, NRL, ARL, you name it. Anybody who's working in the space industry is really somebody that somebody at our place will be interacting with, as well as the commercial space industry that has bloomed in the last decade. SpaceX, Blue Origin, you name it. We're interacting with them corporately, and also the international community. We have strong partnerships across the globe with some of our allies. So that's kind of a very brief summary of what I do and who I am.
Do you have any other panelists next?
Which of us are industry EAC members? I think I missed that. Maybe I should wait until they go first.
I believe all our EAC members have introduced themselves.
Yeah.
Okay. All right. So I'm one of the remaining panelists in that case. My name is Srinivas Bettadpur. I'm faculty in the Department of Aerospace Engineering and the orbits area. Like Scott, right? Not the only exception. I have had only one employer ever in my life, University of Texas at Austin. I came here as a student and just stayed. I think of relevance, the students will get to know me as time goes on, of course, but perhaps of relevance, I want to point out that the university does offer, in terms of career paths, the university does offer several opportunities of growth for students, either as students, interns, that's the most familiar one to you, but several of the students have also benefited from actually starting off with us on sort of early career 1 to 2 year jobs while they're trying to figure out, do I want to go to grad school? Do I want to go to industry? And several labs around the university offer opportunities where students may engage and get a sample for academic life and then decide for themselves if they want to go off to academia or go on to industry and so on. And so the universities do offer those sort of unconventional opportunities for students to be employed, to be productive, and to learn the business and the career path while being at the university. And so that's the one sort of unique point I could make perhaps for the career path, as in my industry, right, academia, because the faculty path is of course well understood. And so that doesn't need to say much about that. And then one other point I wish to make is that I've been very fortunate in my own career path to have had opportunity to work with spaceflight missions all the way end to end, from architecture development, concept development, to the systems engineering for science purposes, and then the science analyses. That is a great part of what informs me as a faculty member. I see visible evidence of it in what I teach and the way I teach it. And so that's the fun part of my job. That and the students are the fun part of my job. So I'll stop there.
Okay, great. Thank you so much. We should have one more professor panelist, but I don't believe he's here, so we will continue on. All right, so our first question that the students of Lunar Council has provided for you is, what software and innovating technology would you prefer that an applicant would be familiar with in your sector of your industry? And anyone can just take it away.
Well, I'll jump in and start, and this is going to be the what I'll call the Bible answer, because everybody knows about this, but it seems like everything that we're doing these days is digital, and design is being done in a digital environment, and the operative term that everybody's using is model-based. So model-based systems engineering, model-based development, model-based mission assurance. There's a ton of MBXs out there, and our company has a big has a big push in that regard. My son just graduated with his degree in aerospace engineering unfortunately from another university, but and started with Ball Aerospace, and the very first thing that they asked him to get involved in was helping the company implement model-based systems engineering. And there's a number of processes and tools associated with that, including things, knowing how to code in Python, or how to use MATLAB, or how to use Simulinks, or several of the other what's the other one, Magic Draw, I think is it called, and there's several others. So I would say that the big answer in that regard is focused on being able to do things digital, in a digital environment virtually, and understand the concept of model-based systems engineering and development.
This is Chad. I can add to that, and I agree with Dan. Certainly, model-based is important at Boeing, and all those tools that he mentioned, and are common at our company as well. And certainly, integrating those together and doing more of it for our programs is certainly an emphasis. Since I'm in the artificial intelligence sort of research group, I just say, and maybe Boeing more broadly, I mean, any software you learn is beneficial. I don't think you can ever learn enough, to be quite honest. I don't, through my career, I've been in aerospace for almost 25 years. I don't think software will ever let you down in this industry, be it on tools and processes or on the platforms themselves. The more you know, the better you're going to be, no matter what your discipline is sort of my take on it. In terms of artificial intelligence, machine learning, I mean, the world is Python, basically. That's the dominant there these days. Ubuntu is the operating system, if you wanted to pick some. And then certainly for autonomy, I think ROS, Robot Operating System, is one of the key enablers that lots of companies and that people use these days. I think also this question asked a little bit about, innovative technology, things like that. I think at Boeing and probably lots of the other companies and efforts, I think technologies around sustainability are just going to be massive, be it electrification of platforms, how do you come up with new fuels to be carbon neutral, things like that are certainly coming. And then I also think, autonomy, automation, and just about everything we do is of interest as time goes forward. And certainly when you get into these aspects from the factory to our platforms, how the humans work with software, with machines, with AI. And one of the big things we weigh is, AI shouldn't exist just to do what AI wants. AI should exist to do or meet humans' objectives and what the human needs are. And so I think there's some important wrinkles there to keep in mind. So anyway, that's a quick perspective on some other aspects of software that are important in aerospace, I think, going forward. Yeah.
I can add a little bit. I mean, I completely agree with everything that was said. I guess the only thing I'd add is, and this is coming from, effectively a dinosaur as far as all these things are concerned, but becoming facile with the development infrastructure, the digital development infrastructure that goes along with all of the software and the technology. I'm finding myself exposed on a daily basis to a million different platforms for communicating and collaborating that I didn't even know were there. But ever since March have become a necessity. And I'm guessing for younger students, these are probably not a big deal, but understanding how software development with something like Git or some other DevOps kind of framework works is probably a good thing to understand, as well as exposing yourself to a lot of the collaboration platforms in terms of how companies and institutions are starting to automate the workflow of how things get passed around and making sure that humans aren't actually responsible for having to keep tabs of what the status of things are and who's got the action to do something.
So I guess I'm just going to reiterate a lot of what people have said here. Yes, software, but I would like to say more than just software. It's coding, and if you learn how to code in one language, you can probably learn easily in a different language. So if you learn C, C++, Fortran, it's going to be a walk in the park to learn Python. So don't stay one step remote from a particular language. Think about coding and programming philosophy, right, instead of a particular syntax. On AI and machine learning, and I think this is probably a theme I'll get back to quite often over the next hour. If you focus on AI and only do AI, you might get cornered. Yes, it's very very fashionable right now. Who knows what's going to be fashionable in 5 years or 10 years? If you focus on the harder topics, differential equations, high-level calculus, partial differential equations, and writing code for these problems, you can pick up AI really, really easily. I hope I'm not offending anybody here, but this is really what I believe. And so keep that in mind. Yes, AI again is really cool, and there seems to be a lot to do with it. But you're gonna have a much stronger toolbox. Again, if you stay one step remote from a particular language and one step remote from AI in particular. So that's my 2 cents. And I think I'll get back to that theme a few more times just to make sure I drive this point across.
Yeah, yes, I resonate with that easily. The fundamentals always rule. That is very clear. In terms of innovative technology, there's something on my mind that actually happened earlier today. We had every summer we have high school interns work with us, and this year about 5 of them came back to describe what they have been doing. And these high school students came in to intern with us during COVID, and so they wanted to do something connected with COVID and socially relevant. So they pulled data in from multiple sources, built it on AWS, Amazon Web Services platform, pulled CSV files from who knows where, whomever had the CSV files on demographics of COVID-19, built the user interfaces, and then decided on the analytics to present. Other people may have made other choices on the analytics. Other people may have made other choices on the mapping. But I think what I did not have, certainly as a learning tool, was this ability to blend, pulling in data, pulling in and writing that software and learning from it. We used to learn by picking up objects. Well, I shouldn't go there, because a lot of us learn by picking up objects by hand and turning them around and staring at them. That's one way to learn. But graphics and graphical tools, I think, are very powerful. People that do experiments, visualization of model output and so on, use it all the time. And I think the modern software technologies and the cloud computing facilities and so on have made learning using those tools very easy. And particularly the students seem to be much more comfortable with this. The younger they are, the more comfortable they seem with these technologies. So there is a huge amount of resources out there in terms of innovation in what you can use to learn. And I think that's a very powerful way to learn. It also makes you proficient with the tools that we were just talking about. And exploit that would be my suggestion. It's waiting there to be exploited. It's all available. It's all for free. It's waiting to be exploited.
Right. Okay. Thank you all for this question. Our next question that we have is, do you have any recommendations for minors or certificates in relation to your specific industry or career?
Systems engineering.
That's exactly what I was going to say. And actually, if you want to go into leadership or management, if you have that aspiration, I would highly suggest you get a minor in psychology. But that's just my 2 cents.
I mean, my industry, what I do for a living is all research and development. Somebody else takes that and turns it into a product. So my 2 puts would be, do something that makes you a more well-rounded person, philosophy, music, arts, whatever. But if you're intent on getting something that's going to line up with your career, then I've never met anybody who regretted taking more mathematics, at least not in the R&D business. So
I would say computers.
Yes, if I would.
Sorry,
Go
Chad.
ahead,
You want to go ahead? Go ahead.
You can go. It's okay.
Okay. Yeah, I was gonna say computer science, definitely, especially given how computing is changing, and it's beyond AI, right? Computing hardware, the way we're gonna do computations 10 years from now are gonna be very different from what we do now, and so if you can combine aerospace engineering and computational engineering with more hardcore computer science courses, I think that would be really strong.
Yeah, I agree with that. I think that foundation, a good foundation in computer science is never going to hurt you. And AI is just a portion, I think, of the overall computer science stack. And like Lauren mentioned earlier, physics doesn't go away, right? And depending on what you're working on, that's still there. There's a lot of work into controllers, reinforcement learning that sort of combine different disciplines, things like that. But I guess one other dimension here is maybe beyond the formal minors and certificates, and just talking about development maybe in general. Certainly and I think I've experienced it, is that experiential learning is maybe one of the best places that you can develop, right? And we're encouraged to really try to make development like 70% of what you do, to try to work that into your daily assignments so that you can really learn it, right? Training, we tend to put an emphasis on about 20%. So that would be your certificates, other training courses you could take, maybe night school or various things. Lots of companies offer that, right? Advanced degrees that you can do on your own time frame. And then we also get into mentoring, right? It's always good if you can line up with other people, and we put a premium on that too. It's like, when we have our development conversations, hey, what are you interested in? Oh, I know somebody that has done that, right? Or knows about that, and then we can connect you up and to get somebody to meet with you regularly and talk through it. And I think there's a lot of value. So I think there's other avenues besides just training and education, I think, that can help develop you as well. So consider that. Thanks.
Can I make one comment here?
Yeah, of course.
Just for the panelists, our computer science department is very closed in the sense that they have too many students of their own, so they don't allow outside students to take their courses at either the undergraduate or graduate level. And this has been a problem, for years. So if you can be more specific about what aspects of computer science you think would be useful for students to know. We try to incorporate as much of that into our curriculum. We try to emulate some of the beginning level computer science courses in our curriculum, but if you just think about that a little bit, because we do have this problem here at UT that our computer science department is closed off from outside students that want to just come and sit in a course.
Basics on computer architecture, which probably tech can offer. Coding beyond Python, right, and MATLAB. So C, C++, Fortran.
Well, computer science doesn't teach coding anymore anyway. I mean, they don't teach programming.
They don't?
They don't teach languages now. No.
But they teach, what do they teach then?
You learn
logic, algorithmics, yeah.
Okay, well, yeah, so well, that would be good. So one course on algorithm design, right? The basics of algorithms, yeah.
Data structures sometimes are helpful.
Yeah, we offer data structures as part of our software engineering and design class. So there's, the two classes, 322, COE 322 and 332 are meant to emulate some of the courses that they perhaps would get from computer science if they were able to get into computer science. Computer science at UT is very theoretical and very different than what you may have grown up with in terms of what you think of computer science. On in a different direction.
Yeah, that's the basis of it. And then, you get into all of the formal proofs and formal methods and things like that as well. But I guess you need those backgrounds, I guess, to evolve to those levels. But yeah, not everybody is necessarily going to do that.
Computer science majors at UT don't go into differential equations or calculus. I mean, they don't go beyond. They take a bare bones linear algebra, and that's the extent of their math.
I would like to ask sort of a related question to the panelists from the industry and from the labs. Something simple like visualization. It's actually non-trivial to do it right, to send the message Is that something that people learn organically, or is it something that you have to train your new entrants at?
So, I mean, in our organization, they learn, but this is, I mean, we hire only PhDs, right? So it's maybe a slightly different viewpoint here that I have, and maybe I apologize for that. But you know, we expect people to be able to learn on the job a lot of things they do, including new languages and new ways of visualizing, you know, data if they need to. So it's certainly not something that we look for. But we expect people to learn on the job quickly, right?
I mean, at our place, we've you know, we've got a lot of people like myself who've kind of come out of either hard science or engineering backgrounds, but when we're building out a technology, a lot of the things we've been doing lately have been you know, software for decision support systems for say the Space Force, which has a heavy you know, kind of human machine interface component, and the way you present whatever it is you're going to present can make a huge difference in, you know, the workload of the operator, or their ability to even absorb, you know, what information you're trying to convey to them. And we've ended up doing a lot of partnering with our the part of our laboratory that does you know, human performance and human effectiveness and human factors. They grew out of, you know, the old part of the laboratory that used to just centrifuge people until they passed out, but they've since blossomed into a group that actually factors, you know, everything from psychology to, you know, haptics to anything that has to do with dealing with the human. So yeah, I mean, I agree that that's an important skill to have, you know, kind of under the broad brush of communications. But you know, to our earlier discussion, you know, maybe a minor in psychology or a minor in art or a minor in some other field that lets you kind of explore, you know, those aspects of you know, how to convey information to a human more effectively is something that people could think of doing.
Thank you. Those are all great points. So for our next question, we're going to switch gears a little bit and ask, what are the non-technical...
Courtney, I'm sorry, we can't hear you.
Oh, thank you for telling me. Can you hear me now?
Mm-hmm.
Okay. My microphone does that sometimes. So to switch gears, the next question is, what are the non-technical skills that aerospace and computational engineering students should have for your industry or your certain career path?
I want to take this one first because I feel really strongly about this, and it's not only aerospace and computational engineering, it's all technical fields and engineering fields. You are only as good as the way you present your technical work. And so presentation skills are very important, both, you know, oral presentation, like, you know, at conferences and to your managers, but also in writing. You can do the best work, technically speaking, in the world. If you cannot present it, it's lost. And so as an engineering student, you absolutely have to learn how to present your work. And so going back to what Richard was saying, it's, you know, if it takes, you know, taking a few classes in psychology or communication to be able to do that, so be it, right?
So do you think something like research would help with being able to present your work in a technical manner?
What do you mean research?
Like research and the publication of that, and then conveying that research, say, in a conference.
You mean as a way to train how to present?
Yeah, right.
Yeah, I mean, that's a good question. Any venue where you can practice your skills, presentation skills, is good. You know, whether it's at a conference, you know, for a student project at the end of the year, whatever, right? But it's, you know, what we see is that some people dismiss the importance of presentations because they think, oh, my technical work is so awesome. I don't need to present. The results speak for themselves. Well, no, they don't. They really don't. So you're you're a weak link if you don't present correctly. Maybe other people disagree with that, and I'll let them chime in. But I've seen. Just to really emphasize or hammer the point here, we've seen people with extremely good skills, but then they're in interviews, right? When we try to hire people, if you cannot present your work, they sometimes don't get the offer, right? Even though on paper they're really good.
Yeah, I'll add to that. Communication is important, and I think when we get out, and since most people here are students, right, and maybe frame this in terms of coming out of college and starting, up at industry or at the labs. I think the tips I give people when they come and are new, right, out of school are, over communicate. And maybe this isn't in the presentation form, but don't assume people know. Just if there's information, share it. Think about, what can I do today to tell somebody something that I know, but they might not know, and over communicate it, right? Just always be active in communicating with others, I think is a good tip to hold. For us, I think ability to learn is humongous, especially in our research and development area. We build teams based on, this person knows this person knows that to solve this problem, but you never know everything. Your team is never complete, and there's always that deficit that people are going to have to go figure out. And so we do a lot of assessment of how well people, can learn, if they have enthusiasm for it. I think for us, at Boeing and probably lots of other places, we speak in tons of acronyms. We have our own language, and I tell people, don't get discouraged. Just spend 6 months of asking silly questions in the acronyms. Get immersed in the language, because there is a different one typically, so that you can come up to speed and be more comfortable. It's okay not to know and to ask. I also tell people, build your network. I think jobs and opportunities I've had in the company is because I knew people up and down the hallway where I used to sit, and I actually, for some bizarre reason, but it worked out as a good strategy, is whenever I had a chance to work on a project, I left the people that I knew and I went and sat with the people that I didn't know. And what I tell people is build your network and get to know people. There shouldn't be a person in your cube or your office space that you don't have some idea of what they do. Go ask them, find out. These are the people that will move and be your friends, your colleagues, your collaborators, farther down in your career. And certainly I think in interviews and other things, we really want to know, can people solve problems? And I think when you have projects at school, this is just a rich area for you to, I think, getting to what Laurent was saying, is tell us a story, build up, communicate, what you know and how you learned and what problem you solved. And that's a communication technique right there that sort of convinces us that, you stitch together all of these bits and pieces into a nice thread, I think, which is hugely valuable. And certainly, on the psychology theme, and maybe this is early in your career or later, but I think all of us have read psychology books or articles, and it's hugely helpful to understand other people. And that's kind of a surprising one, isn't it? But it's certainly true. Some of the best books I've enjoyed have been psychology based. There you go. Thanks.
Well, and just add to all this, because this is something I'm also very passionate about. Your people skills are your best skills, and I'll argue with anybody that the way you get ahead is like Laurent said, is presenting yourself and relating to others and communicating, like Chad talked about it, in being willing to get out there and serve others and be a part of a team and a bigger part of it, or part of something larger than just yourself. We all are addicted to our phones. We all communicate with our thumbs these days, and we do a lot of looking down. And what we need to do is look up. We need to your skills, your ability to relate to someone is going to really help you in your career. Your ability to communicate with them, to talk to them, to present your work, like has been said, to to also to listen to you. You know, we were given 2 ears and 1 mouth, so there's a reason for that. You know, so being able to listen, and we operate. You know, one of our favorite sayings in my company is, people don't care what you know until they know that you care. And that's something that we really like to implement, and that's part of the relational activity. You know, we're all people. You know, you've heard people say, you know, it's not personal, it's just business. Well, I think that's a bunch of baloney, because everything's personal, because we're all human beings. So we all operate at a personal level. We all operate in our own personal space, and being able to relate to others and communicate to others and to present to others and to care for others are going to be your greatest skills, and they will help you the most in your career. They certainly have helped me, because I'll be honest, I wasn't a good student. I didn't do well at school. And my career has been built based on the ability to use my people skills and my relational skills, because it certainly hasn't been on my technical acumen, unfortunately. So anyway, for what it's worth, what these guys are saying is absolutely true. You got to be able to present, you got to be able to communicate, and you got to be able to relate and to care. And if you can do all those things, you will do really well.
Yeah, I can make just two small additional comments. I mean, just to everybody's point about being able to communicate, whether it's written or whether it's oral. You know, on the government side, we get all these proposals, and I always feel bad. I mean, we get to see proposals from the best and brightest all across the country. The issue we always have is we're given very little time to review them. And so that's really where the communication skills become very important, because a really brilliant idea explained really poorly and a mediocre idea explained really well, when you don't have all the time in the world to review the two, can look frighteningly similar to each other. Or maybe even the good idea looks bad compared to the mediocre one, because at least the mediocre one you can understand. That's unfortunate, and it shouldn't be like that, but life's not fair. So that's one. And then the only other thing I'd mention too is, um, developing your skills in terms of relating to other people kind of in a one-on-one dynamic, but also like understanding the dynamics of teams and how teams either work or don't work. Because very rarely does somebody end up with a job, in any kind of engineering or anything for that matter, where you're not actually going to be part of a team. There's very few single person armies out there that kind of do it all themselves. So getting a better understanding of team dynamics and how you can take a team that isn't functioning maybe optimally and try and help it function optimally, is a good skill to have.
All right, so for our next question, we're going to skip to number 6 just for time. And our question is, what areas in aerospace and computational engineering are exciting or very fast growing?
I can start this one if you'd like. I mean, this isn't the right word, so Chad, don't take this the wrong way, but the infestation of machine learning, AI, and into everything. It's going to be like trying to buy a laptop without a lithium ion battery in it pretty soon. You may not even know it, but somewhere in everything you buy, there's going to be some facet of machine learning and AI, I think, very shortly. But beyond that, our increasing use of fully autonomous platforms where all of this autonomy is integrated in with a physical hardware as opposed to just, a program that you interface with over your laptop. In my area, in the space side of things, there's a lot of really exciting things going on. The complete kind of explosion of the commercial space industry, along with all the startups and things that go along with that. And then, most recently, within the last 2 years, we've just stood up our first new military service since 1940, whatever. When we birthed the Air Force out of the Army, we've just now birthed the Space Force out of the Air Force, and that's having kind of huge ripple effects in the community I work with, and it's definitely causing a refocus of exactly what the the mission is. So these are all like very huge muscle movements that I think they're causing a huge amount of excitement and turbulence that goes with it across the whole industry.
I'll talk about not aerospace, but computational engineering. I'll let the others speak about aerospace. So I believe we're at the beginning of a very important transition in computing, like we haven't seen in maybe 25 years. This, and again, this is beyond AI. This is the way the computing hardware industry is changing. And the reason for that is because computing is, Moore's law is slowing down, and we need to find new ways of sustained growth in computing performance. That's going to be through quantum computing for some specific applications, specialized hardware, massive parallelism, analog computing is coming back. And so there's going to be tremendous opportunities over the next 10 years in developing new algorithm for these new emerging computing hardware. And that includes, how you use AI in using these emerging computing technology, right? So it's going to be fast growing. It's going to be very exciting. And that's also why I said that, if you can get your hands into some of the computer engineering or computer science courses to help you ride that wave of excitement, that should be great.
Yeah, I can add some thoughts too. I guess when we talk about AI, one of the things that my group focuses on at Boeing is more on what I call AI-enabled systems. So these would be decision systems perception that go on platforms quite a bit. And so really when you develop these, there's a whole mod and sim infrastructure, there's hardware in the loop, there's, testing in the real world. These things don't work out of the box, right? It's like you actually have to test them in the real world. You're never quite as smart as you think you are. And I think that all of that requires a lot of capability, how people can do it fast, I think is key. But I guess more autonomy, more AI enablement where it makes sense and it can buy its way on, just to condition that. I don't, compute for some of these systems is way too much, and maybe, traditional computer vision or other methods work just fine or better. Maybe you don't have data-rich environment, right? So your application isn't going to cover these things. So really, it's like another tool in our toolbox, right, to address certain classes of problems and performance that we need. Beyond that, I think that, at Boeing, I think a lot of people think about the products we make and design and manufacture. Boeing's big at manufacturing. We don't operate those as a kind of quirk in history, right? We don't operate our products. That goes to the airlines, that goes to the government. But we do a lot of business after that, which is in the support and services. How do you keep these things maintained, operating efficiently? I think we might have talked a little bit earlier about digital twins, digital thread. How do we, operate, maintain? What are the performance levels? There's a lot of modeling, simulation, data all coming together, and I think computational engineering ties quite well into those. But I think even at Boeing, we make 60%, at least a few years ago, was on the support and service side of our revenue, which is kind of surprising, but it's true. So is Boeing a aerospace product company, or are we a support and service company? I guess the real answer is both, right? Some people don't think about that sometimes. Thanks.
On the aerospace side of it, perhaps it has some intersection with the computational engineering too. But if you read the stories about these mega constellations coming up, what I find interesting is how they are learning on the market side. At least the services is where the revenue is. It's just you don't just throw up the rocks. You actually convert the data they're collecting into some information, some intelligence, and so on. I think that's going to require a lot of humans that are probably not correctly trained at this moment, is my guess. And so that I think is an area of growth, unless the whole industry collapses. I mean, I don't know. And related to that too, I think I would invite a comment from my colleagues in the industry. Space seems to have become more accessible in the sense that it used to be an arena for the larger entities for a certain number of decades. And now there is a proliferation of smaller entities. And so therefore, contributions can be made at a smaller scale without requiring billions. If perhaps my colleagues could comment on that.
I can make a quick comment on that. I mean, that I personally think that's been almost a direct result of our ability to produce satellites that are much, much smaller and yet still have a great deal of functionality in them. The success of SpaceX aside, in reality, it still costs a huge amount to get a pound of anything up into orbit. It's less than it used to be, but it's still a lot of money. But that pound actually does orders of magnitude more than a pound used to do. So that's really where I think the benefits have come from. And so the bottom line is now the barrier for entry to produce something that could function in space has gone way, way down. And in addition to that, the volume and mass has gone down. So now you can join with other people who have produced something small, and you can do these launches of, say, 23 or 40 or what have you CubeSats all at once, and spread the pain of the launch cost across all those people, and yet still, do your part once you get up on orbit. So for me, that's been my perspective, what I've seen over, say, the last not really 20 years, but accelerated a lot in the last 10 for sure.
Okay, great. So for our next question, we are going to skip to question 9. And this is, can you describe the impact of graduate school for your line of work, therefore describing whether it is beneficial or not?
It is required. Well, sorry. In the research organization, I mean, again, I work at corporate strategic research, which is a fundamental research lab. So we do require people to have a PhD in physics, chemical engineering, computational mathematics, whatever. Trust me, this is not true across the entire ExxonMobil organization, right? I mean, you can have a degree in engineering and get a job, but so yeah, I mean, for research, you have to have a PhD. So,
I mean, yeah, I mean, I work at the Air Force Research Lab, and we don't hire very many bachelor's students, but that's primarily because what need we have for bachelor's we're usually getting from the officers that are coming to us straight out of the Air Force Academy or the ROTC to their first assignment. And so what bachelor's needs we have are usually met by the officers at AFRL. That won't be, but we do hire quite a few masters and PhDs. I think last I checked, we're about a third on all of the degrees. But I think that's also a function of the fact that we do, like I said, basic research all the way to prototyping and life cycle, as opposed to just basic research where, yeah, if we didn't have all PhDs, we wouldn't be doing a very good job. We produce satellites and we have to fly the satellites, and there's people who with a bachelor's degree who are much better at actually flying a satellite than I will ever be, despite the fact that, I've been the PI on 6 of them. You wouldn't, there's some situations you wouldn't want me at the console for. So, so it depends on what aspects you want to go into, even at our research lab, given the breadth we have.
Yeah, I'd tend to agree with that. I think I'm in research and development now at Boeing. A lot of people with PhDs. We definitely hire them, and we tend to have a group of, I would say, like researcher type people, usually PhDs, and then engineering. So we usually have a mix. But I think more broadly, I mean, you can focus on a career in engineering, certainly can do fine with bachelor's. I think a lot of people will go to school at night, and probably our population during your career, probably over half will eventually get some advanced degree as well. But yeah, I mean, you can certainly come out of school and work at a company with a bachelor's, right, in industry. Sometimes that's a good experience for going back later, or a lot of times even Boeing, pretty much we've got a program, and I'm sure other companies do, where if you want to go to like part-time program at one of the universities that have to offer it, you don't even have to put any money down. It's like Boeing will just reimburse you for any of that educational expense. And I don't think we're unusual in that. So if that works for you, some people want to go back to school. And I think sometimes, you know, at least if you work in our group, we'll also help try to place you with different professors, right? So we've got relationships. We work quite a bit with universities. And so it's always good to get to know them if you do want to go back to school. But again, our group is definitely limited. I think for Boeing, we've got 150,000 people worldwide, and research and technology is only about 4,000, right, for that. So it's a much smaller population just to be aware of. Thanks.
This one observation, I don't know how true this is because I haven't done an extensive search with conversations with my colleagues in the industry. My general impression is that an engineer's life over the decades has been getting more complex / difficult, whichever way you use. The tools that we commonly use are ever more sophisticated. And so a bachelor's degree practitioner or a master's degree practitioner is probably using more sophisticated tools or more that have more knowledge inside them than they used to 20, 30 years ago. And I always felt there was perhaps a halfway point between a bachelor's and a master's. It takes a long time to learn how to process GPS. And you can imagine a lot of jobs that don't require a PhD, where you would like to have proficiency. I take the example of GPS because I know that. And so how do you put in that time? Do you put in that time in a certification course? Do you put in that time in getting in the process of getting a master's degree? It certainly doesn't require a PhD. That's very clear. And so the modern tools of the trade in engineering, they certainly are getting more complex. And so there is probably some intermediate degree there to be had. I'd like to hear your opinions on that. I saw some nodding heads.
Yeah,
something resonated with that.
Totally agree with you. And look at it this way, right? So a bachelor's degree has been 4 years for how many years, how many decades? And, 50 years, whatever, right? It's been 4 years. Technology has advanced, over the last 50 years, dramatically. So why is there this? And that's why. I mean, that's why now it's so difficult when you just have a bachelor's degree to grasp everything that's happening. It's probably not enough anymore. So I totally agree with you that maybe going to 5 years. I guess the students don't want to hear that, but or getting a master's, because that's gonna make you more ready for the complex technology out there. Yeah. I mean, we cannot continue to have only 4 years of study and hope for tackling everything. Or you're gonna have to be very narrow in a field, but then how do you adapt yourself to everything else, right?
Let me offer, and certainly these are all excellent points, and you're right. Let me offer a bit of an alternative view in that, I think that there's a lot to be said to what somebody picks up when they get into industry and start working. And everything that I learned while I was working. I learned at school how to tackle a problem, and I gained foundational information but certainly when I got out into the workforce and I started working, and I got with more experienced people than me, who were mentoring me and caring for me and helping me to pick up the skills that I picked up along the way. That was even more helpful. And I've heard over and over and over that in industry, and this has to this is a little bit different if you're in careers that are more research focused or whatever. That in industry, the terminal degree is a master's degree, and that is certainly is the case in my company where we employ PhDs. We have about 15% of our employees are doctorate level or postdoctorate level, but most of our employees have master's degrees, and very few are like me where they stopped at the bachelor level. But essentially, getting a master's degree is what people tend to do. But I'll brag about my son real quickly, and then I'll get off the stage. He recently went to school for 5 years, and he got a degree in aerospace. He got a bachelor's degree in aerospace engineering degree. I'm sorry, he got a bachelor's degree in aerospace engineering. He got a bachelor's degree in piano performance, and he got a master's degree in aerospace engineering, including completing a thesis and presenting his thesis. So he literally he got all that in 5 years. And the poor kid's got circles under his eyes, and he's tired, but he did really well. He graduated with honors, and he got 3 great degrees. But I'm not sure all that's necessary. I mean, he did what he wanted, and he did great in it, and he's got a great job now and making good money, and he really loves what he's doing. But it just really depends on what you want to do with your life after you get out of school. I mean, that's the honest answer. What do you want to do? Do you want to get into research? Well, like they've said, continue on and get the right degree. If you feel like you want to go and work for the space station program or go to SpaceX, I mean, maybe a bachelor's degree is okay. Like for me, because I did just fine too. It really is very personal or independent, so to speak. But I tell you, in our industry, a master's degree is basically all you need for what it's worth. So not trying to contradict anything anybody else has said.
All right, so for our next question, we just briefly wanted to ask about the computational engineering degree. So how much awareness is there for computational engineering, and what is your impression of the major?
I can go ahead and start. I was first made aware of it just because I'm on the EAC, and Texas was rolling it out, and that was the first I had ever heard of it. And I've been kind of tracking it, from that perspective since then. Although I will say I've now since heard at least 2 or 3 other schools start to say they're now going to start rolling this out as well. So congratulations, Texas was at the vanguard of doing something new, as far as I know. My impression of it, again, goggles are just seeing it through the EAC kind of perspective, is it still seems like it's searching out what it's going to eventually be. I think there's a lot of push and pull going on between coding and physics and numerics and maybe machine learning, and how those are all going to sort each other out in terms of what part they play in the computational engineering still seems like it's going on. But that doesn't seem unreasonable for something that is trying to do something new that we haven't got a good, playbook on how to do. So it's going fine. But it probably seems a little turbulent if you're in it, I'm guessing. My Great Dane apparently does not agree with me in the background here.
Yeah, I mean, I agree with that. I guess I notice when we get resumes, it seems like lots of universities have lots of different majors now, and sometimes it's hard to track and compare one program to the next. But I do see in computational engineering, it seems like there's a base of programs doing that, so I think that's good. Definitely, I mean, for what we do in aerospace and sort of manufacturing space, there's a lot of work there. It will continue on, right? It will be important. Physics is a key thing to model and to be aware of, and not only doing that from the sort of compute side, but also a lot of the testing and other things you have to do in engineering to make sure things work right, and that loop back. So I think it's a good discipline. It's an important discipline. I think it's got a good runway of need, as we go forward. Who knows? I mean, looking back in my life, it's like 5 years is a big horizon, right? Like if you would try to go back 5 years and know or see where the world is today, I mean, that's a long time, really. So, I mean, I think it at least meets that 5 year horizon, which is probably the best you can predict.
I want to go back to what Richard was saying about it's a turbulent field, and that's why the computational engineering major is turbulent, right? Because there's a lot going on in computational science. As I mentioned, computing industry is changing, AI. That's probably why everything is still in flux, and I think we need to recognize that. So the next thing I'm going to say, I think I'm going to take some flack for that, but that's okay. I'll take a risk. I think the computational engineering major is probably more general than aerospace engineering, and therefore it gives you more ability to work in a broader field out there. If you spend 5 years, 4 or 5 years in studying aerospace engineering, that's going to be pretty specialized right away. I think, as far as I understand, computational engineering gives you the tools to tackle many more problems. You could definitely go into oil and gas. You can go into biomedical after that, because you understand how to solve physical problem, develop mathematical models, algorithms, and then learn how to implement them on a computer. That's everywhere. That's what we do everywhere. So, but that's my bias, right? This is my field. So
It's interesting you should say that. There are actually statistics from some years ago from our department that a large percentage of our undergraduates were employed by the oil and gas. Aerospace undergraduates went into the oil and gas energy industry, generally speaking, the energy industry, which is always interesting to me.
Yeah, so we're not hiring as much today, but
yeah.
Well, I think aerospace has always been multidisciplinary, right? And so, I mean, you make a good point.
Okay.
But yeah, I think, just from my undergraduate and graduate school and looking at where people have gone and been successful in lots of different industries, I think, you might not be doing aerospace, 20 years from now, but you'll probably be doing something interesting with the basis that you got. And I don't disagree that computational engineering isn't, a great place to build up your skills and be very marketable as well. So it's probably more like what you learn and, what you're interested in. And I guess that's the thing I think about too. It's like, if you get a job someday, you're going to be spending at least 40 hours, and likely, if you're like some of us, probably way more than that. That's a big portion of your life. You better enjoy it more than you don't enjoy it. And yeah, that's, I think, a key thing going forward. So do what you like, or at least do more of what you like than you don't like.
I think a quick, setting aside the awareness, since I'm in the department, one comment I will make is that the COE program does seem to offer room for students to go searching for applications or project. There is, I think, 1 or 2 classes that they can sign up for where they can go searching for other disciplines inside the engineering and work with people that are actually that they're not seeing in their classroom for the 4-year program, to step outside their program. And I think students do take advantage of that, because we do things that might appeal to the computational engineering students. And from what I have, first impressions, I will say the students also seem to be aware that they can reach out to PGE, they can reach out to electrical engineering, and so on, to add spice, so to say, to their curriculum.
Or even outside
of Cockrell School. Yeah.
A lot of we cross list with geology,
yeah,
neuroscience, I mean, some students take electives in neuroscience, in economics. So we allow for a broad range of electives.
Yeah, well, that's a very rich option. Yeah.
Well, I wanted to give a chance to go to the audience Q&A.
Oh, yeah, very, very quick point. So to go back to what Chad was saying, that, you know, whatever you choose in engineering, I mean, you learn how to learn. And that's priceless, right? I mean, and I think that was said before, so it doesn't matter as much, because you learn how to solve problems and you can learn a lot of stuff. I mean, it's a, I don't know, you get a degree in learning capability, if I want to say so.
Yeah, so for our audience Q&A, this is now the chance for anyone to ask some questions if they had any. And let's see. Yeah, everyone should be able to unmute themselves if they have any questions.
I have a question. So knowing what you all know now and considering the course that you took from your degree to your career, what is one thing that you would change, or do you have any advice that you would give to students that are going to be going through this process as well?
I certainly would have applied myself harder. I would have done better in school, and I think, I'm not sure I was capable, but and also I would learn more about some specific topics. Like one topic that is very important in the spacecraft business and in the aircraft business as well is what I call mission assurance. So understanding the concept of things like reliability, supportability, resiliency, the ability of a system to outperform its overall design, a life, or to perform to its requirements is incredibly important, and it's something I didn't really get a whole lot of when I was in school. And if you get the opportunity to focus on learning about mission assurance, I think that's incredibly important, and it will serve you well as you get into a career, especially if you're going into the development field or the research field, because thinking in what I call failure space is very important. You got to know how things fail and what causes things to go wrong, so that you can design for that. So I think that understanding mission assurance would have been very important to me for what it's worth.
So this might not be a hugely popular opinion, and maybe I have the luxury of saying it because I work for the government. But I think if I had it to do over with, I would probably trust my instincts on exactly what the urgency and the importance of some of the things that I ended up doing actually were. There were plenty of times where, despite looking pretty hard, I couldn't really understand why an activity that the Air Force had decided was important, but it needed to be done, and so I ended up doing it. And I think with probably significantly greater than 50%, I find now in retrospect that I was right, and that a lot of those things never went anywhere, and they weren't actually that important. So I think people should just make sure they give themselves a very strong vote, where they have the option to anyway, in terms of what to spend their time on if they have multiple options.
I got into college in the physics program, and then engineering came along and I shifted, and I wish I stayed in physics if I had to do over. But for the longest time, I thought like that. But eventually what I realized was I wish I had understood then that it's more important to be a good engineer than to be a good aerospace engineer, if that makes sense. I think someone said, maybe it was Chad that said earlier, you don't know what you're going to be doing 15, 20 years from now. Prepare yourself for that while you're an undergraduate, to have that mental flexibility. So.
Yeah, I guess maybe I could add one. I mean, I've worked at a big company. I've enjoyed that career. I don't have any regrets. I guess I always feel like I was more of a small company startup kind of person, but I've kind of navigated my way and have more of that type of environment in my daily work. So maybe that's something I would have considered if I wouldn't have had, family and things like that, sort of tempered my willingness to give it up with lots of risk, right? But I don't really regret it, but that's something I think about. It's like maybe it wasn't more fun to be smaller and nimbler. So sometimes big companies and governments, right, we have some bureaucracy, less movement. But I don't know. On the flip side, I wouldn't really like to be, scrounging around for dollars and not knowing what my future would be the next few months. And so I guess it's a balance when you think through those types of things. So yeah, maybe if you're going to try that, do it earlier in your life. Very good.
I have one more question. So I'm actually getting a minor in French, and I wanted to know how feasible it is to be involved in the research aspect of engineering in another country, because I know ITAR is a pretty big deal, but do any of you have any experience doing research abroad?
As a student, you should have no limitation to you. There should be no obstruction to you being a student anywhere in the world.
Yeah, I mean, I work for the military who, ostensibly would be the ones you would think would be all freaked out about this, but within AFRL, we actually have a program. I think it's Worlds on Science or Worlds on Engineering or something like that, where we can apply and we find a contact at a research institution in another country, preferably a friendly country, obviously. And the Air Force actually will pay us to go over and do research there. Now, I'm making it a little simpler than it actually is, but the bottom line is that's an option even for us. We're encouraged to, partner all across the world. There's a definite understanding within my management chain that not all the good ideas are going to be invented here, and that we work with our allies, especially all across the world. So I agree. I wouldn't let anything hold you back from doing it. Just explore what the options are and pursue them if that's something you want to do.
Yeah, I mean, I don't see any reason why you wouldn't do it. I mean, my job, I've got people in Korea, Beijing, Bangalore, Australia, Jeddah, Saudi Arabia. So we are international. We do research around the world. We do coordinate. There is ITAR and EAR, different regulations you have to deal with. But yeah, I mean, I think if you're going to be a global company or industry, right, it makes sense to have people doing work around the globe. I guess even when I went to Texas, I had an opportunity, since we had several people from DLR in Germany, that I worked an agreement to go spend the summer there doing work. Yeah, and it was a lot of fun, great experience. I think if you learn languages, that probably won't let you down, right? Open up the door for those types of things. I will say my toughest class, I only dropped one class in my whole career, and it was German, which I was trying to cram for before I went to Cologne to take this internship. And I found that I was spending 80% of my time trying to learn German, and I was doing my aerospace classes, so I had to drop it. But yeah, don't let that discourage you. I think especially there's just tons of opportunities to go international, and I think, I don't know about computational engineering, it might even have more advantages to go international, because I think defense and aerospace tends to be more regulated than a lot of other industries where it really doesn't matter as much. So that's another thing to think about. So anyway, go for international. It's a global world out there.
I'll end on a soft note. I can answer to you in French if you want, because I speak French. The other thing, so Chad, don't listen to this, but you can work for Airbus. I mean, they're a French company. No, seriously, I mean, what Chad said, right? It's there's a lot of opportunities out there, so it shouldn't be a problem.
So the time has hit past 5 o'clock. So we're going to start wrapping this up. And I'd like to thank all of our panelists and everyone else who came so much for coming to the event. And let's go to the next slide. Yeah, thanks everyone for coming. If anyone has anything else to mention, this would be a great time to do it. And if you have any questions, we have our email there, or you can email someone in the department. And this is the LUNAR website if you wanted to check it out.
Thanks, Courtney, for putting this together. And
yeah,
great job. Good job facilitating, and thanks folks for coming in, and thanks to the panelists for participating.
Thanks for having us. It was fun.